First, I just want to, in case I don't have time at the end, just to acknowledge our lab, a number of our collaborators. In particular, I'd like to highlight Steliana Yanakeva, who led the study on time perception, and then my colleague, Clement Lemercier, who's been leading the work on response to suggestion under the influence of microdosing. Okay, so I'm going to describe two quite different studies, but I can come back to the link between them if anyone's interested at the end. So a distortion in the experience of time is a common feature of different types of altered states of consciousness. This is something that's observed in dissociative states, meditative states, hypnosis, psychedelics, a number of different types of contexts. We believe this is because how we experience time represents a fundamental feature of our conscious experience of our environment, of ourselves, and informs a wide range of different types of psychological functions. Now, we know that LSD produces subjective changes in our experience of time as measured by various types of self-report and subjective measures. And extending beyond this, however, our understanding of how it might impact time perception is indexed by kind of more standardized behavioral measures is less well understood. So as you can see by these dates, there's some older studies that were relatively good for the time period in which they were conducted, where they found distortions in the perception of time, but with some variability across the results. Independently of work on LSD, there was a really nice study a little over 10 years ago by Whitman colleagues showing that psilocybin produced a tendency to experience durations as to under-reproduce durations, which we might expect to see, for example, in the context of LSD studies on temporal reproduction. One of the reasons why we're interested in time perception, in addition to its fundamental feature in various types of altered states of consciousness, is that timing seems to be especially sensitive to various types of manipulations. So we thought if microdosing is impacting cognition or perception in subtle ways, that performance on a time perception task might be especially sensitive, so we might be able to pick up on these effects. So this was hinted at in earlier studies where psilocybin would impact your perception of time, but not necessarily your performance on other types of psychological functions. Okay. So to take you through the general methods, so this paper was published earlier this year, so I'm going to go through it fairly quickly. So we had 48 healthy older adults in the study. They underwent a 28-day screening period, followed by a 3-week dosing period and a 4-week follow-up period. On different days, they were randomly assigned to either a placebo, 5, 10, or 20 microgram dose of LSD. So they would receive different types of different doses on different days, okay, and they would be dosed every 3 days. It's important to emphasize the experimenters were also blind, so this was a double-blind experiment. They also completed subjective drug effects, different types of self-report measures, indexing different features of experience that might potentially be altered under the influence of microdosing that were completed regularly, and I'll come to that in a moment. The main data here was collected with a temporal reproduction task, which is a standardized measure that's widely used in the literature. This is a particularly good task for this type of study because it's very easy to understand, it's very easy to implement unlike psychophysical tasks, which we typically use in the laboratory, which we're a little bit nervous might not really be amenable to this type of context, particularly with elderly adults who are microdosing. So the way the task works is participants are presented with a stimulus on the center of the monitor, might be just like a blue circle for an extended period of time ranging from 800 to 4,000 milliseconds. Afterwards, they are prompted or cued to then hold down the space bar to try to reproduce that interval. Okay, so it's just, and then we look at their reproduction times across different stimulus intervals. So first, just to look at the subjective drug effects. So here we have time. The black line corresponds to when they completed the task on this 4th dosing day. We looked at 5 different subjective measures, so drug effects, perceptual distortions, and a few others. Basically, what we find is we don't find any really robust differences between LSD and placebo conditions in terms of these subjective drug effects. There is a small effect if you do very exploratory specific analyses at 180 minutes in terms of the subjective drug effects. This is a relatively small effect size. Now, so basically, this is kind of a mixed result. There seems to be a detection that they're able to pick up that they are in the microdosing condition, but the effects are certainly not robust. Then, interestingly enough, we do not find any dose effects, though. So we do not observe any significant dose effects. So it's not as if you're in a higher dose condition, you report greater subjective alterations. But keep in mind the sample sizes, that we really only have 12 participants in each group that might account for some of these underpowered effects. In terms of the effects on temporal reproduction, so here we have the x-axis, the different stimulus intervals, we have the reproduction times, and the y-axis, placebo in green, LSD in blue. The principal result was that in the LSD conditions collapsed across doses, there's a tendency to over-reproduce the intervals that extended from 2,000 to 4,000 milliseconds. So fairly consistent effect, but it was most pronounced in this interval range of 2,400 to 3,600 milliseconds, with basically effect sizes in the moderate range. Now, what we do is we also do within participant regression analyses where we fit a least squares regression line to each participant's data on a trial-by-trial basis. So we can then fit a kind of a line or a slope here to this. And what you find is that the LSD condition is characterized by a steeper slope. And that's something that figures into the interpretation I'll provide a little bit later on. Now, the second measure is the coefficient of variation, which provides a measure of temporal precision. It's basically just a measure of variability. And this is something you typically see distorted in various types of clinical populations. We do not see any differences in temporal precision, though, across the two conditions. Now, we weren't super nervous, but we were a little bit nervous that some of these effects might be driven by the subjective changes where we observe these subtle effects. So to control for that, we do what's known as hierarchical regression, where we look at whether the subjective drug effects can predict these differences in time perception, and then look at whether LSD versus placebo predicts additional variance above and beyond that, just to kind of show that the effects are completely independent, and that's indeed what we find. So we find the subjective drug effects do not reliably predict these reproduction times, and that condition, namely whether they're in the LSD or the placebo condition, predicts a significant amount of the variance above and beyond that. So basically, in short, what this tells us is that these observed effects here appear to be independent of the subjective drug effects that we've measured. Again, we've only measured these 5 simple measures, so if we indexed a wider range of effects, then those might come through, of course. So when we look at dose effects, the dose effects were far less compelling, at least when we do simple ANOVAs. So basically, you get a couple of effects here that were on the borderline for statistical significance, although the effect sizes are actually slightly larger than in the drug effects. Some of these effects are a little bit more sensitive, though, and we pick up on them when we look at these slope effects. So when you look at the slope effects, you actually start to see some dose effects with the largest dose characterized by the steepest slope. And this, again, figures into the interpretation I'll be providing in a moment. Again, no differences in temporal precision across the conditions, so it's not like the LSD conditions are characterized by elevated variability, for example. Again, I won't repeat this, but basically we find the same thing with the hierarchical regressions. These effects appear to be completely independent of any subjective drug effects. Okay. Now, when we wrote the paper, we presented a number of different interpretations, and we were never completely happy with the interpretations we had. They felt a little bit speculative due to our lack of knowledge about microdosing and a number of other features. So in the wake of this, we've been kind of thinking a little bit more about the data and what might be going on here. And independent of work that we're doing on psychedelics and time perception, other work we're doing on time perception, we've been thinking about timing in the context of Bayesian models of perception, and we think this type of framework provides a potentially nice kind of parsimonious explanation of what might be going on here. Okay, so based on Bayesian inference and Bayesian models of time perception, you have a simple sensory likelihood, which basically corresponds to sensory information that you're picking up on in your environment that's going to correspond to the actual objective duration of a stimulus. Then you also have a prior, and the prior might be built from expectations, statistical regularities in your environment, whatever it might be, and that the prior can then, to the extent to which it is weighted by the individual and in particular context, ends up shifting to posterior, which is what your subjective experience is. So this gets shifted away from the objective stimulus interval towards the prior, for example. Now, this type of model provides a nice parsimonious account that really nicely explains a lot of the temporal reproduction effects in the literature. When applied to temporal reproduction paradigms, here this green line corresponds to the objective stimulus interval, and this is the sensory likelihood. This red line corresponds to the average, which is basically the prior. So we believe that the individual accumulates over time an average of what the stimulus durations are, and that functions as a prior in this type of task. Now, the blue line corresponds to the actual reproduced durations. Now, this is a well-known effect that was first observed in the 19th century, which is that participants tend to under-reproduce long intervals relative to the objective truth, and they tend to over-reproduce short intervals relative to the objective intervals, okay? So what we believe is going on, what a number of authors have proposed, is that basically this is due to prior weighting. So basically you weight the influence of the prior, and that shifts the reproduced intervals downwards, so you get this tendency to under-reproduce the intervals. Now when applied to our data, where we get this over-reproduction, what this seems to suggest is a down-weighting of the priors. Okay? So basically they're no longer seen to be using the priors to the same extent, they're down-weighted, and then this leads to a tendency to over-reproduce relative to the placebo condition. Now an interesting prediction that arises from here is we wouldn't expect just a tendency to over-reproduce intervals, but rather we would expect a shift in the slope. So one of the consequences of down-weighting is that this line here should actually go down. So they basically should start to under-reproduce the short intervals. And if you look at the data, there's actually a numerical tendency for that to happen in the 20 microgram condition. And the best way to pick up on this are these regression slopes. Okay, so we basically expect a steeper slope when people are down-weighting their priors. And that's exactly what we have. So in the 20 microgram condition, you have the steepest slope, which is consistent with its down-weighting of priors. Now, independent of this work, we recently came across Robin Carhart-Harris and Carl Frisson's new NEBUS model, in which they specifically propose that psychedelics are characterized by a down-weighting of priors. So it fits very nicely. They're focusing on higher level priors. We would argue that these priors are probably kind of in the middle range within the brain's functional hierarchy, but this account is potentially consistent with their model. Now, Dimitris was talking a lot about our conceptions of microdosing and the way it's presented in the media, and I think we need to really be informed of kind of how people are talking about these things. So it is also important to not overhype these results and present them and acknowledge that they are preliminary, and also to assess them and evaluate them within the context of the limitations of the study. So I just want to briefly acknowledge a few of these. So first of all, our sample sizes. We only have 12 participants in each group. This isn't too bad for this type of literature. Nevertheless, there's a good chance that we're underpowered. In particular, some of the dose effects may have been underpowered that might not permit us to pick up on some effects. So that's something that needs to be considered. The second is we do not actually have a baseline. Participants are randomly allocated to the task in different conditions. We never measured temporal reproduction outside of the context of the drug, okay? And this would provide us with much more valuable information regarding prior weighting, okay? Now, the random allocation mitigates this as a problem. Nevertheless, it would still be valuable to have a baseline. And then finally, the demographics. So basically what we're doing here is we're measuring these effects in older adults, okay? So older adults are an interesting population with regard to temporal reproduction. So for starters, they exhibit biases towards temporal under-reproduction. So it might be that the microdosing is almost kind of returning them to baseline, and that's an effect that we might not observe in younger adults. We also know that older adults are characterized by reduced striatal dopamine, which is the primary neurochemical implicated in timing. So they're kind of our atypical population with regard to some of the effects here. So we might not necessarily expect these effects to generalize to younger adults. That's something we do need to keep in mind. Okay, now turning focus a little bit. A major focus of the work in our lab is on the phenomenon of suggestion. So suggestions are communications for involuntary experiences. So here's a woman undergoing surgery, and a hypnotherapist is giving her suggestions for modulation of her experience, for reductions in pain and so on, in the absence of any kind of local analgesics. Okay? So we know that suggestion can be an effective and powerful way to modulate cognition and perception in a number of different ways. We also know that it has demonstrated clinical efficacy. So suggestion is one of the primary variables, the causal mechanisms underlying phenomena like hypnosis. It plays a very important role in the context of placebos and a whole host of other different types of conditions. Now, suggestion is potentially very important in the context of psychedelics. So we know that LSD seems to enhance suggestibility based on work by Carhartt-Harris and colleagues, but also older studies which seem to indicate that. There's overlapping neurophenomenology, okay, between highly suggestible individuals in response to psychedelics. So some of the effects that you observe with psychedelics are observed in highly suggestible individuals at a smaller scale at baseline. So for example, with alterations of default mode network, reductions in lower levels of alpha power already at baseline, and so on. Okay? So we think that these highly suggestible individuals might be especially prone to some of the effects you see in the context of psychedelics. And one of the strongest predictors of suggestibility is the tendency to get absorbed in one's environment, so absorption, and this is also known to be a strong predictor of response to psychedelics. Finally, there's an older tradition of exploring the idea whether you could use suggestion to shape the psychedelic response. So there's this really nice old tradition of what's known as the hypnodelic technique that was developed in the 1960s, where they were coupling hypnosis in the context of psychotherapy with psychedelics, with the idea that you could harness the value of the possibilities of suggestion to shape the psychedelic response in various ways. And we've explored this in a more recent paper that we published last year, led by Clement Lemercier. So on the basis of this, we want to see to what extent microdosing might modulate response to suggestion. And this can also be informative with what Demetrius was also talking about in terms of potential placebo responses, because there is evidence to indicate that suggestibility is a predictor of the placebo response. So basically, if microdosing is enhancing suggestibility, this can then have downstream effects in terms of modulating placebo response. Okay, so this data was drawn from the same study, but it was completed on a separate day. Our collaborators were interested in the extent to which suggestion would modulate learning. And so this was all placed within the context of a learning task. So participants briefly learned 6 shape-color associations. Some of them were accompanied by suggestions to have rapid associations, so that whenever they would see the shape, they would automatically experience the color in a systematic, automatic way, almost kind of resembling phenomena like synesthesia. They completed 240 trials, and we can look at their error rates, their learning patterns, and things like this. And then they received a cancellation of the suggestion at the end. Okay, so the suggestion would no longer be modulating their cognition and perception anyway. So a trial would look like this. They would see a simple fixation. They would then see a stimulus, which could be one of 6 different shapes, so just simple basic shapes like squares, triangles, and so on. Again, we wanted to have a fairly simple task, given that we were working with elderly adults in a microdosing context. They then had to make one of 6 responses, just using a response box corresponding to different colors, and then they would then immediately receive feedback. And we basically just look at how they learn these associations over time, whether that's modulated by LSD, and then also we can compare suggested versus unsuggested associations to see if there's an effect of response of the drug on response to suggestion. I should also just briefly say these data are a bit preliminary. We've only been looking at them very recently, so I just want to kind of present these with a bit of caution that we are going to be doing some further analyses to get a better sense of what's going on, but I thought this might be of interest to the group here. Okay, so first what we have here is the cumulative error rate. So these are basically the extent to which they're making errors over time. And basically they make a lot of errors initially, but then it tends to flatten out as you'd expect as they start to kind of form fairly robust associations. Okay? Now when you look at the overall error rate, the LSD conditions are characterized by a greater error rate than the placebo condition, but it's not statistically significant, and the effect size is very, very tiny. So we do not really think there's any kind of change in the global or omnibus error rate. When you look at the dose effects, the high error rate in the LSD condition seems to be characterized or driven by the 10 microgram dose condition, as you can see here, with 5 and 20 actually slightly lower than the placebo condition. Overall, there doesn't seem to be any kind of modulation of error rates per se. Then we look at the time course of response times over time. You can see that these basically look fairly similar, and when you compare the mean response time, the LSD condition is slightly fast. Participants in the LSD condition are slightly faster than those in the placebo condition. The effect size is much larger than in the error rate effect, but again, this is non-significant, so we're not making any strong claims. There may be a slight tendency for the LSD condition for the participants to respond slightly faster, but again, there is a potential for a speed accuracy trade-off. When we look at dose effects, again, the 10 microgram dose condition appears to be impaired to the greatest extent with the slowest response times. Then we also have a learning rate parameter, this alpha, which is based on a log measure of how the response times decline over time. And this provides you with an index with higher values indicating greater learning rate. There's a tendency for the LSD condition to be characterized by a higher learning rate with a relatively good effect size, but again, this did not achieve statistical significance, okay? And we do not observe any clear-cut dose effects. So all in all, the LSD conditions do not seem to be modulating learning at a global scale in this task. Now, obviously, microdosing in other contexts potentially could facilitate learning. I don't want to make any strong claims about that, but at least in terms of our data, we're not observing any clear-cut effects. Now, when we look at the response to suggestion, we parse the trials based on those where there was a suggested association for the shape to automatically trigger the color, those that were suggested versus those that were unsuggested. So in the placebo condition, the suggested is in green, unsuggested in blue. There's no obvious suggestion effect. In fact, numerically, it's in the opposite direction. So this is a bit unusual to see in a suggestion context where it usually facilitates performance somewhat. But in the suggested trials, they're actually performing slightly worse in terms of the error rates. By contrast, when you look at the LSD condition, we have a fairly robust suggestion effect. So this was highly significant with a relatively large effect size. So participants are doing much worse in the unsuggested trials. Now I want to be very clear because I don't want this to be misinterpreted, is that in the suggestion condition is not necessarily facilitating better performance. Because if you actually compare this against these, they're actually fairly comparable. It seems to be that in the unsuggested condition, they're doing worse. So why that might be the case, there's a number of kind of interpretations. Nevertheless, there's a clear difference in these suggested and unsuggested conditions, suggesting that the LSD is modulating suggestibility. Now, it's important, of course, to compare these and look at the statistical interaction. And indeed, there is a condition by suggestion interaction with a relatively large effect size. And then briefly, when we look at dose, the effect is numerically present in all three dose conditions, but it's only significant in the 5 microgram condition, not in the 10 or the 20. The 10, it's kind of borderline. There's some kind of trends towards some effects here, and numerically the effect is present. But unfortunately, in the unsuggested condition, we have very, very high levels of variability. So the suggestion seems to really kind of tune a high degree of performance, a stable level of performance in these conditions, whereas in the unsuggested condition seems to be characterized by a very high level of variability. Then when we compare these different conditions, all three of these are either statistically or suggestively different from the placebo condition. These two conditions are characterized by smaller effect sizes with only kind of suggestive p-values. Basically, and there's no significant dose differences across these three conditions. So on the whole, this basically seems to indicate that we're not getting clear-cut dose effects here. If anything, there might be a trend in the opposite direction with smaller effect sizes relative to placebo with higher doses. Okay, so these are kind of some somewhat bewildering results with regard to dose effects. Nevertheless, there does seem to be some preliminary evidence here that LSD seems to be enhancing responsiveness to suggestion, even though this doesn't translate to a clear performance benefit. Now, in terms of the interpretation, unfortunately, at the present moment, we do not have a robust model within cognitive neuroscience of how suggestions affect cognition perception. There's a number of different kind of competing models of how suggestion exercises its effects in the context of placebo, hypnosis, other contexts, and there's a lot of ongoing debate. So unlike in the temporal reproduction data where we have a fairly good, a robust model, we do not have one here. So nevertheless, there are a number of potential interpretations. One is that the data is consistent with a number of research studies showing that LSD might basically enhance context sensitivity. So Carhartt-Harris and colleagues have a nice paper about this from last year. So it might be that basically the microdosing is enhancing slightly context sensitivity. We know that suggestion is quite closely tied to contextual cues in one's environment, and that highly suggestible people tend to be heavily shaped by contextual factors in their environment. Another account is a predictive coding model that was presented earlier this year. And the basic idea is, in the interest of time, I'm going to only go through this very quickly. It's basically the exact opposite of what you see in a temporal reproduction context, where basically a prior would shift someone upwards towards responding to the suggestion. So this has basically the exact opposite effect of what we would observe in the temporal reproduction context, which is that the LSD is actually enhancing the weighting of the prior. Okay. Now, this can potentially be reconciled with the downweighting of the prior in a temporal reproduction task, depending on where the priors exist within a functional hierarchy, right? And so on the surface, it kind of looks like it's inconsistent, but they potentially could be reconciled. A third interpretation, in probably one of the kind of the most dominant models in contemporary experimental hypnosis research, is that these effects are driven by a downregulation or a decline in meta-awareness. So there's a number of studies showing a reduction in meta-awareness seems to facilitate response to suggestion, and we have data that we're nearly about to submit showing that highly suggestible individuals at baseline are characterized by a disruption of the coordinated medial prefrontal cortex and frontal parietal networks. Okay, and there's TMS evidence in favor of this and so on. So it might be that microdosing is basically attenuating higher level meta-awareness. This in turn leads to a facilitation of response to suggestion. As you can see, there's a number of kind of interpretations. Some of them are kind of competing. Some of them are potentially compatible. Okay, so briefly, just to summarize. So we find that microdose LSD produces a tendency for its temporal over-reproduction. We think this is best accounted for within the context of a Bayesian model of time perception in which LSD mediates a decline in prior weighting, leading to steeper slopes of these temporal reproductions. And this is consistent with our data, as well as a number of kind of other accounts and a recent model, this NEBUS model of the effect of psychedelics. In the second study, we find that microdose LSD seems to enhance response to suggestion, even though it doesn't translate to actual performance benefits. So this is consistent with a wealth of different studies. There are multiple interpretations, and at present, we're not necessarily ready to endorse a specific interpretation because they're very much in competition with one another. Okay, I'd just like to thank you for your attention, acknowledge everyone here, and then just very briefly, we're conducting ongoing research where we're looking for participants. We're in the middle of doing a study on nitrous oxide, so if anyone that's based in London is interested in participating in this research, definitely get in contact with us, please. Thank you for your attention.